Good morning, everyone. Welcome to Vertical Academy. This video is about looking at parallel and perpendicular lines. So, particularly, this topic is about linear equations. So, for some of you who have not actually subscribed to my channel, please do so in order to get more information about this topic called linear equations, or per se kind of an introduction to linear programming. So now we want to talk about parallel and perpendicular lines. First of all, we have to understand what is a parallel line and what is a perpendicular line. So to start off with, we shall start with the parallel lines. Okay. Now, what you need to understand is these are parallel lines. For example, if I have an x or y plane, okay, this is a y-axis, this is the x-axis. Then there is 0. Now, what you need to understand is when something is parallel, okay, then they are not going to meet actually. So I was going to draw a line that is parallel to the y-axis, okay, then it's going to be kind of straight like that, okay. So meaning that this line and the y-axis, they are parallel to each other. So another point is that if you want to actually draw the line that is parallel to the x-axis, then this line is going to be something like this, so that the parallel, this line parallel in black, it's parallel to the x-axis, okay. Meaning that, what does this mean now? What this means is that parallel lines have the same gradient, okay. They have the same gradient, or rather the slope. So the word slope and gradient, they just mean the same. So from there, then what are we talking about? We know that in the previous video we looked at the general equation of a straight line, which is y equals to mx plus c. So this is a standard equation of a straight line. Now in this straight line equation, we know that the m is actually the gradient, okay. Is actually the gradient, and the c is normally called the constant. But the key point is that on this one, it's supposed to say parallel lines have same they have the same gradient, okay. So now what we are saying is that if I have the equation, let's say for example y equals to 3x plus 1. So that is our equation 1. And then also I do have another equation, let's say y equals to 3x plus minus 4. So when you look at the two equations, by just the virtue of looking at them, you'll find that the coefficient of 3 and there the coefficient of 3, that is the gradient. So The gradient in this case is just 3. So if two lines have the same gradient, meaning if m1, meaning the gradient of the first equation is equal to the gradient of the second equation, then we can conclude to say that these two equations are parallel to each other. Okay, so these two equations are parallel to each other. Okay. So now, after knowing that, then we can actually we can now look at an example. Okay. Now, so for instance, in this example, we have an equation which is 2x minus 3y is equal to 7. Now, this line passes through a point. This line is parallel, okay? We have this equation, okay? And it passes through a point where on the graph, let's say p is negative 6, negative 2. Then how can we find the equation that is parallel to this line? Now, the thing is this. If this equation is parallel to a line which has got a point negative 6, negative 2, then we are saying that this 2x minus 3y equals 7. Then we can find y by making y the subject. So by making y the subject of the formula. So in this case, it's going to be 2x minus 3y is equal to 7. So therefore, I'm going to make y the subject by saying negative 3y. I'm going to say 2x, 7 comes to the left, comes minus 7, equals to negative 3y, goes to the right, becomes positive 3y. So what you do there is you divide both sides by 3. So this one threw out by 3. So the 3 goes. So therefore, your y then becomes y equals to 2x minus 7 over 3, of which I can now just expand that by saying that each of that term is divided by 3. So therefore, y equals to 2x divided by 3, and also 7 divided by 3. So by looking at the coefficient of x, then we know that the gradient of this line is is 2 over 3. So now, what you're saying is, if the other line passes through the point, this, and the second gradient that we have found, since the lines are parallel to each other, so our gradient is this. Okay. And we know we know that we can simply now find the constant c. So we know the standard equation is y equals to mx plus c. Then I need to find c. So because negative 6, substitute where there is x, and negative 2 substitute where there is y, and m where there is this m, I'm going to put 2 over 3. Okay. Okay, so then negative 6 is equal to 2 over 3 multiplied by x. So it should be this should be negative 2 is equal to the m is 2 over 3 close bracket, and my x is negative 6 plus c. So now I'm going to multiply both sides of the equation by 3 in order to get rid of this negative. So this will multiply by 3 throughout. Okay. So from there, this is going to be negative 6 is equal to 2. This is going to be this negative 12 plus 3c. Then from there now, I can correct the like terms. Negative 12, negative 6 plus 12, meaning 12 comes this side, is equal to 3c. So I know that this is going to be 6 equals to 3c. And now from there, we can simply say that to divide both sides by 3, and this goes. So I'm just going to have 2 equals to c. So that is our value of c. Now what we're going to do is just a matter of now replacing. We know that the gradient now is 2 over 3, and our c is 2, so therefore our y equals to mx plus c. So y equals to our m is 2 over 3 x plus 2. Okay, so that is our equation that is parallel to the other equation. Okay, so the most important thing is actually to ensure that you make y the subject, okay, so that you can simply specify just the number that is coefficient to x. Okay, so thank you so much, and I will see you in the next video.